Unit 3 practice test. A Ferris wheel completes a full rotation every 40 seconds. That's a Ferris wheel. Ferris wheel's day off. Remember that movie? I changed it. The center of the Ferris wheel is 55 feet above the ground. I didn't leave myself a whole lot of space, so let me just draw a circle thing with the center on it and say you're going to be 55 feet off the ground. The minimum height of a gondola is 3 feet above the ground, so that would be you at the very bottom where Drake started. You're 3. A passenger boards gondola number 8 when it's at its minimum height. Cool. What is the height of gondola 8 exactly 1 minute after the ride begins? Well, last time I checked, boys and girls, 1 minute is 60 seconds, right? So you take one complete rotation. That's 40 seconds. Now, you're here again at the very bottom, and 20 seconds later, you're at the very top. So that's where we are in this. We're at the very top. So I need to figure out how high off the ground the very top is. Well, between the center and the very bottom, we're looking at a difference of 55 minus 3, which is 52. So up here is going to also be a difference of 52. And 55 plus 52 is 107. So the maximum height of this Ferris wheel is where you're going to be after 60 seconds, and that's going to be at 107 feet. Fun stuff. The periodic function g of x is graphed below, so this is going to repeat the same exact way. I'm not even going to attempt to draw it, but it's going to repeat the same exact way every however many. What is g of 43? Well, the period of this guy is going to be 6 minus 1, which is 5, which means this whole process repeats every 5 units. So if I wanted to find out what g of 43 is, the last thing I want to do is try to draw this all the way out to 43. So let's use common sense. Okay, if this repeats every 5, then 43 divided by 5, the remainder of that is going to give us our behavior. So 5 divided by 43 is 8. 8 times 5 is 40. Subtract, we have a remainder of 3. So g of 43 and g of 3 are going to give us the same exact location. And g of 3 gives us a point of 1. So g of 43 is also going to be 1. Find the coterminal angle of negative 43 pi over 16 in the range 0 to 2 pi. So a coterminal angle, or a regular angle for that matter, is going to be something that lives in between 0 and 2 pi. Those are the same. So if I wanted to find some angle that's not in this zone between 0 and 2 pi, I either add or subtract 2 pi. Anytime I add 2 pi, I'm literally going around the same exact circle and landing in the same exact spot. So adding 2 pi doesn't change anything. Subtracting 2 pi would be the same exact thing. Now, since I live in negative land, what I need to do is add 2 pi and see if that lands me in that zone right there. Now, adding 2 pi isn't going to look so pretty here. So instead of adding 2 pi, I'm going to multiply the top and the bottom by 16, 32 pi over 16. I'm using common denominators. So let's add 32 pi over 16. By adding 32 pi over 16, that gets me negative 11 pi over 16. Now, I'm not in that sweet spot yet between 0 and 2 pi, so I keep repeating it until I land in that sweet spot. So let's add 32 pi over 16 again, and that's going to give me, no way, 21 pi over 16. 21 pi over 16 is in between 0 and 2 pi because 32 pi over 16 is 2 pi. So you would be my answer, which means you would also be my answer. The answer is A, baby. An angle with a measure of 5.7 pi would be equivalent to which of the following angle measurements? Well, any angle, right, no matter what it looks like, is going to live somewhere on a circle here. Okay, 0 and 2 pi are the same thing. So if I were to take this number and add 2 pi to it, if I were to take that angle rather, so are we giving it, so if I call it theta, if I were to take angle theta and add 2 pi, I land in the same spot. Similarly for this problem, if I subtract 2 pi, I land in the same spot. So what I need to do is I need to take 5.7 pi and subtract 2 pi as many times as I can until I run out of stuff. And my job here is to select all that applies. So I have to make my way all the way down to negative 5.7. So I'm subtracting 2 pi a bunch of times. So subtracting 2 pi gets me 3.7 pi. None of those are an option. So let's do it again. Subtract 2 pi is going to get us 1.7 pi. None of those is an option, but I did pass 2.7 pi, so words are hard. So at least I can cross that out. Let's subtract 2 pi again. That's going to get me negative 0.3 pi. So that is an option. Let's do it again. Minus 2 pi is going to get me negative 2.3 pi. So we passed u and didn't land on u, so that's not an option. Let's keep going. Minus 2 pi is going to get me negative 4.3 pi. That's not an option. Looks like all we have to do is one more time. Minus 2 pi is going to get me negative 6.3 pi, which I passed u. So D is the only option. After all of that, D was the only option that seemed to work. So D is going to be our only answer. We are given a circle here with some pieces of information. Now those pieces of information are the circle, when flattened out, goes all the way out to 6, which means I have a radius of 6 here. Okay, I have this angle A that's spun around, and after the angle A is spun around, I land on a coordinate with an x value of 2.6 and a y value of negative 5.4. This problem is asking me to find the sine of that angle. Now, there's shortcuts here, but let's remember what sine means. If we go back to SOHCAHTOA, and we're looking at a perfect right angle, right triangle like I just did, we have the opposite side and the hypotenuse. Okay, the sine of alpha is the opposite over the hypotenuse. Opposite over the hypotenuse. When I compare this to this, the hypotenuse is always going to be my radius, and the opposite in this case is going to be my y value up and down. So sine alpha is going to be the opposite, which is y, over the hypotenuse, which is r. So try to memorize the fact that your sine is going to be y over r. In this case, my y is negative 5.4 and my r is 6. So sine alpha is going to equal negative 5.4 over 6, which is going to be b. So once you have this memorized, life is going to be a lot easier when you run into problems like that. Find cosine of alpha. Well, we're given a circle here, and this circle, when flattened out, stretches all the way out to 6, which tells us this circle has a radius of 6. Now, if I take an angle and spin it around, I land on an angle alpha that also gives me the coordinates of 2.6 as an x and negative 5.4 as a y. Now, my focus here is on cosine. So we remember back from geometry that SOHCAHTOA, the ca is the cosine, and the ca stands for the adjacent side. Okay, this would be the opposite side, and we're focusing on alpha right there. That's the opposite side, and you're the hypotenuse. Ca stands for adjacent over hypotenuse. So cosine is the adjacent side over the hypotenuse. If we're comparing these to things on a coordinate plane, the adjacent side would be the x value, and the hypotenuse would be the r value. So cosine of alpha is going to be the adjacent side x over the hypotenuse, which is r. So memorize that. Memorize that cosine is x over r. Once you do that, I can look at this information over here and say, all right, well, my r is 6 and my my x is 2.6. So cosine alpha is going to be 2.6, my x value, over regular 6, my r value. And that is going to give me a over here. A. That's how you do it. In the xy plane, angle ABC is an angle in standard position with terminal ray BC, which intersects the unit circle at the point with the coordinates 0, 0.6, 0, -8. Let's draw ourselves a unit circle quick. A unit circle has a radius of 0, so we can put a point over here that's 1, 0, and we can say that my radius is 0. What I'm doing is I'm making an angle that the ray of the angle lands on the point 6, -8. 6, -8 lives in quadrant 4. So this angle that I'm calling, I don't have the name of the angle, so I'll just call it alpha, is going to spin around, spin around, spin around, and land somewhere over here at the point 0.6, -0.8. You are my x value, you are my y value. Now it's asking us which of the following descriptions is correct. Each of the descriptions is talking about sine. So the sine of an angle is going to be the y value over the r. In this case, my y value is -0.8. My r is 1. So sine of an angle is going to be -0.8 divided by 1, which is -0.8. So the sine of this angle is going to be -0.8. The answer is D. What is the cosine of 5 pi over 6? If you haven't memorized the unit circle yet, you need to. Now let me draw out the unit circle so I can visualize this better. Okay, terrible job by me, but you know what, beggars can't be choosers. You're 0, you're pi, which means you're pi over 2, which means you're 3 pi over 2. When you're dealing with the unit circle, every quadrant has 3 dots living in it. Now I care about the angle 5 pi over 6. The angle 5 pi over 6 is more than half a pi but less than pi, so we're thinking quadrant 2 thoughts. All right, every quadrant has 3 dots that we're focusing on. Okay, 5 pi over 6 is going to be that dot right there. Okay, so the angle that's created is this angle right here, and 5 pi over 6 is going to be that one. Now, when you build the coordinates on a unit circle, what you're doing is you have an x and you have a y value. I always start with the x value. I'm not hyper-focused on positives or negatives right now. I'll deal with that in a minute. But the way that I handle these is I always build from the x value and work my way up at 3 pi over 2. You would be 2 pi over 2 and then 1 over 2. I'm sorry, root 3 over 2, not pi. Root 3 over 2, root 2 over 2, and 1 over 2. And then I work my way down with the y's. Okay, so again, let me show you that. Let me just quick show you that. Root 2 over 2, 1 over 2. Then I work my way with the y's by doing the opposite. Root 3 over 2, root 2 over 2, and then 1 over 2. Now, this is quadrant 2, which is the negative x value and the positive y value. So I'll make sure I throw negatives in front of u. Now, we're hyper-focused on this point right here. Cosine is the x value. Okay, so you have a cosine theta, you have a sine theta, and cosine is the x value, and that's what we want. So what I'm going to do is, since I care about this point right here, is I'm going to label the x value right there at that point, which happens to be negative root 3 over 2. So the cosine of 5 pi over 6 is going to be negative root 3 over 2. And that's how you do it. What is sine of negative 3 pi over 4? Well, first things first, I don't like negative 3 pi over 4. So I'm going to change that, okay, so that I have something within 0 and 2 pi. What I do is I could take negative 3 pi over 4 and add 2 pi to it. Now, adding 2 pi does me no good, so what I'll do is I'll add 8 pi over 4, and that gets me 5 pi over 4. So now I'm being asked the question, what is the sine of 5 pi over 4? This is unit circle stuff. If you don't know your unit circle, memorize it. You're going to need it. I like drawing it out every time because my ADHD brain needs me to. So here's a unit circle. You are 0, you're pi. You are pi over 2, and you are 3 pi over 2. 5/4 lives in between pi and 3 over 2. So 5 pi over 4 is going to live in quadrant 3 somewhere. Whenever you're looking at a unit circle, every quadrant has 3 dots that you're focused on. Okay, 3 dots that you're focused on. 5 pi over 4 is going to be an angle that stretches around here and lands on that middle dot. That is my 5 pi over 4. Now what I do is I need to build my coordinates for these. So I like to build the coordinates by using this method that I do because it helps, again, my ADHD brain. Okay, I have 3 points here. That's the first parentheses, that's the second, that's the third. I'll worry about negatives and positives later. Right now, I just want to build my numbers. Always start out with the x value closest to the x-axis and make that root 3 over 2. Then you build it. Root 2 over 2, root 1 over 2 is 1 over 2. Then you go backwards with root 3 over 2, root 2 over 2, and then root 1 over 2, which is 1 over 2. This is quadrant 3. Everything in quadrant 3 is double negative. So negative, 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 negative. I care about 5 pi over 4, which is going to be this quadrant, or this coordinate right there. I also care about sine. Points on a coordinate plane are given to you as cosine theta, sine theta. So sine is going to be my y value. So more specifically, I care about negative root 2 over 2. Which means at the end of the day, sine of negative 3 pi over 4 is the same thing as 5 pi over 4, which is going to be negative root 2 over 2. Easy peasy. Actually, it's not, but fun pun, which I do a lot of. Like and subscribe. An angle in standard position is given by theta equals pi over 6 radians, and the circle is centered at the origin with a radius of 4. What are the coordinates of the point of intersection of the terminal ray of the angle and the circle? All right, well, a regular coordinate, now I'm given 4 possible coordinates here. A coordinate usually in xy form, when you're thinking trigonometry thoughts, is given to you as r, the radius cosine theta, as your x value, and r, the radius sine theta, as your y value. I already know that r is 4. That's going to make life easier. What I need to do is I need to see what happens when theta is pi over 6. So I go over, I look at my unit circle, okay? Pi over 6, keep in mind, is going to be in quadrant 1, and pi over 6 is that first dot. That first dot is going to be the point root 3 over 2, 1/2. I care about both of these. Both of these. So if I want to find my x value, I'm going to do that x equals r cos theta, and y is going to equal r sine theta. So let's focus on x first. X is equal r, which is 4, cosine theta, which is pi over 6. The cosine of pi over 6 is going to be root 3 over 2 because it's the x value over here. So 4 times the square root of 3 over 2, which simplifies out to 4 over 2 is 2 root 3. Okay, so that's going to be my x value. My y value is going to be done similarly. Y is going to equal my radius, which is 4, times sine of pi over 6. Sine is the y value, which is 1/2. So 4 times 1/2 is 2. So x is 2 root 3, y is regular 2, which gives us the point 2 root 3, 2. Which is going to be A. Isn't that fun? In the xy plane, the terminal ray of angle theta in standard position intersects a circle of radius r equals 6 at the point 3 root 2, 3 root 2. What are the values of theta and r? Well, what I know is I know that if I have a point, my point is going to be in the form r cos theta for x, so the radius times the cosine of my angle. And my y value is going to be r sine theta. Okay, I know in this case that r is 6, right? I also know that x is 3 root 2, and 3 root 2 is also y. So the equation that I'm going to set up, when I normally would set up x equals r cos theta and y equals r sine theta, I'm going to set up two equations. So let's do it one at a time. My x value is 3 root 2. My r is 6, and cosine theta is cosine theta. Divide everything by 6, divide everything by 6, and you're going to end up with cosine theta equals 3 over 6 is a half, so root 2 over 2. Now we do the same thing over here. Okay, my y in this case is also 3 root 2. So 3 root 2 equals 6 sine theta. Divide everything by 6 like we did last time. 3 over 6 is a half, so root 2 over 2 is going to equal sine theta. So basically, I need to think, all right, well, where on the coordinate plane do I have an x value of root 2 over 2 and a y value of root 2 over 2? So we draw out our unit circle. X and y are both positive in this case, so we're talking about quadrant 1 here. And so in quadrant 1, we have 3 possible points. U would be root 3 over 2, a half. U would be root 2 over 2, root 2 over 2. And U would be 1/2 root 3 over 2. U are the one that we want. U happen to be exactly halfway between 0 and pi over 2. And half of a half is a quarter, so the angle that I care about is going to be pi over 4. So my angle is pi over 4. I already know what my radius is, so I don't know why that was even an option, but that leaves me with A here. So pretty fun stuff. I like it. The figure shows a circle of radius 6 along with the origin and 3 labeled points in the xy plane. If the coordinates of x are 3 and negative 3 root 3, so let's write that out, what is the measurement of angle AOX? Well, this is what we know. We know that if we're talking about unit circle type things, we're also talking about angles, and we're also talking about an xy point that we are given. So here's my xy point. We know that the x value is r cos theta, and the y value is r sine theta. So what we do is we take the fact that, well, all right, well, r cos theta is the same as 3. So let's write that out. R cos theta is the same as 3. And we also, and by the way, well, we'll get there. We also know that r sine theta is the same as negative 3 root 3. What else do we know? Well, we're told that r is 6. So we can substitute that in, and now we can do a little bit more math. 6 cos theta equals 3. Now let's write that out over here. 6 sine theta equals negative 3 root 3. Let's focus on solving this guy completely first, and then we'll take it from there, and then we'll get to the next one. If we divide everything by 6, divide everything by 6, cross U out, cos theta is going to equal 1/2. Okay, now over here, we have divide by 6, cross U out, sine theta equals negative. Now, 3 over 6 is 1/2, so root 3 over 2. So let's view this again as a point. We can see from the picture, and we can see from this guy, that this is the point where we have an x value of a half and a y value of a negative thing, and if it's positive, negative, that lives in quadrant 4. And if you're thinking quadrant 4, and let me get rid of this point so I don't have to look at it anymore. Whoa, where's my eraser? Why isn't my eraser working? That was weird. If I look at this point, I have other points living in quadrant 4. So I look at these points right here and I focus, all right, well, this point right here would be the same as, and I like to build these and then deal with these, with the negatives and positives when I do. So let me quick do that. Always build the x-axis first, and you start, the point closest to the x-axis, and you start out with root 3 over 2, root 2 over 2, root 1 over 2, which is just 1 over 2. And then you work your way back. Root 3 over 2, root 2 over 2, and root 1 over 2, which is 1 over 2. Quadrant 4 gives us right 1 down something. So this is going to be positive, negative, positive, negative, positive, negative. Okay, and this guy matches up with that point right there that we kind of automatically assumed. Now, that is the first point after crossing over 3 pi over 2. After crossing over 3 pi over 2, that first point is going to be the angle 5 pi over 3, which is going to be D. Crazy stuff. Where is f of x equals cosine x concave down on the interval between 0 and 2 pi? Let's graph cosine x, shall we? Cosine x starts up here, goes down, comes back up, repeats. All right, now let's label everything that we know. If it's a regular cosine x, it starts up here at 1, bottoms out at negative 1. Its period is 2 pi, which means halfway through is pi, and it crosses the x-axis at pi over 2 and 3 pi over 2. And of course it repeats, but again, we're just only, caring about between 0 and 2 pi. I care about where it's concave down in this case. So in this particular problem, it's going to be concave down between u and u. That's concave down, now you're concave up, and now you're concave down again. So those intervals, plural, those intervals are going to be between 0 and pi over 2, and also 3 pi over 2, and 2 pi. And I guess technically in this problem we should include the 0 and include the 2 pi because we're including it here, but that wasn't given in the option, so I'm not going to lose sleep over it, but that would be the case if we're talking about concavity. So yeah, in the end, the answer is C. This problem is but. We are given an angle theta in standard position as shown in the figure below. So here's my figure. It's a nice, it's spun around, lives somewhere in the fourth quadrant, yippee-i-o. The function g is defined by g of a equals sine a. So we'll deal with that in a minute. For an angle alpha, which is me, not shown, alpha is in between theta and 2 pi. So there's some angle in between here, right? That's also spun around that lives right there. Which of the following is true? So we have, you plug in alpha, you get some information, and then we'll see what happens. So let's see what they're trying to ask, all right? You're going to plug in some point. You're going to plug in some point, and you're going to use the sine function to get something. Now, the sine function is going to be a y value. So when you look at these 2 points, you have this point which has to do with theta, you have this point which has to do with alpha. You're looking at these 2 points, which means what you get, the y value, is going to be g of theta here for this one, this black dot right here, and this red dot, the y value, is going to be g of alpha. What happens here is if we're looking at y values again, no matter where I put this dot, and let's see if it'll let me move it. Will it? No, it won't. Let me see if it'll, here, let me try this button. There we are, all right. So what this is basically saying, okay, is I could put a g of alpha anywhere between u and u, but no matter where I put it, it's going to be above g of theta. So in this case, no matter what happens, since sine is y, g of alpha is going to be higher than g of theta, which means g of alpha is going to be greater than g of theta. So a very bizarre problem. Not a huge fan of it, but these problems do show up like on AP Precalculus Practice Tests. So that's why I put it here. So hope my description helped a little bit. For the function f of theta equals cos theta, what are all values of the domain when f of theta equals 1? Let's look at this from a graphical point of view. So let's draw out cos theta. All right, cos theta starts up here at 1, and then bottoms out, reappears, bottoms out, reappears, and blah-de-blah-de-blah. Bottoms out at -1, and it has a period of 2 pi. So u would be 2 pi, so u would be 4 pi, so on and so forth. Okay, you're 0. Now we care about when this is equal to 1. Okay, so when f theta is equal to 1, we have this line right here. What a perfect line that I just drew. So these points, these graphs intersect at 0 and 2 pi and 4 pi. And if we were to keep going, 6 pi, 8 pi, all the even pi's. So the answer for this one is going to be A for those reasons. So again, you're looking at where my regular cosine function intersects 1, and that happens every 0, 2 pi, 4 pi, every even pi, including the negatives if that's what we had to do. But yeah, that's your answer. A sinusoid has been vertically shifted and has the following maximum or minimum values. Maximum value is 40, minimum value is 28. Now a sinusoid is basically a sinusoidal function, looks like this. So you move it up where your maximum is now 40 and your minimum is now 28, like so. Which is the equation of the midline and the amplitude of the sinusoid? Well, the equation for the midline is given to you as a y equals, because it is an equation, y equals whatever your maximum value is plus your minimum value is, and it's divided by 2. The midline is the line that directly cuts your sinusoid in half. So you're kind of thinking it as the average, and that's what I get here. So my maximum value is 40, my minimum value is 28, divided by 2. We add those up to get 68, and 68 divided by 2 is 34. So my midline is the equation y equals 34. That's my midline. My amplitude is going to be very similar, but it's half the distance of the total max to min. Okay, so it's going to be from here to here, but half of it. That's the amplitude. So we will say that the amplitude is going to be the maximum minus the minimum all over 2. So 40 minus 28 all over 2 is going to be 12 over 2, which is 6. And so my amplitude is a height of 6. So midline is y equals 34, amplitude is 6. The answer is A. The daily low temperature of a certain city over a period of time are modeled by the sinusoidal function in the xy plane. Sinusoidal function looks like this. Much better than that though. The minimum daily temperature is 18 degrees. The maximum daily low temperature is 50 degrees. Based on these temperatures, which of the following is the best value for the amplitude of the sinusoidal function? Well, the amplitude is basically you take the maximum value, subtract out the minimum value, and divide it by 2. You're looking for not the total height, but half the total height. So in this case, my maximum value was 50 minus my minimum value was 18. Divide that by 2. You get 32 divided by 2, which is going to be 16. So the answer is C. The figure shows the graph of a periodic function f in the xy plane. What is the frequency of f? Well, in order to find the frequency of f, we must first find the period. The period is how long it takes for the function to completely repeat. So if we look at 0 and see how it's matched up with 3, it completely repeats at 3 again, 8 units later. Okay? Now what the frequency is saying is like how many rotations or how many periods would you get for every 1 unit. But a better way of looking at it is that the frequency is going to be 1 divided by your period. So in this case, the frequency is 1 divided by, since you were 8, 8. And that's going to be A. Which of the following statements is true about the graph of the function f of theta equals 3 sine theta? Well, 3 sine theta has one change, and that's the amplitude. Okay, sine normally looks like this, so I'm just going to draw a normal sine function like so. But since there's a 3 in front of it, that is a vertical transformation, or rather a vertical dilation, and it goes up to 3 and down to negative 3. Okay, repeats at 2 pi, you would be regular pi, peaks out here at pi over 2, bottoms out here at 3 pi over 2. Okay? So, we need to find the true statement. Okay? The amplitude is 6. Well, the way you find the amplitude is you take the maximum value, which is 3, and subtract the minimum value, which is negative 3, and divide that by 2. 3 minus negative 3 is 6. 6 divided by 2 is 3. The amplitude is 3, not 6. You're not a true statement. And again, we can see that because the amplitude is half of the total height. The function is above the x-axis on the interval pi over 2 and 3 pi over 2. Well, at pi over 2, here, we are above the x-axis, but it dips below the x-axis at pi and is now below the x-axis at 3 pi over 2. So this is not a true statement because it's only above the x-axis between 0 and pi. So you're not true, which means you're not the one I want. The absolute maximum is when f of theta equals 3. Well, there's 3. It's going to be the absolute maximum right there. That is a true statement. Now let's look at see why D is not false. Or not true. The limit as theta increases without bound is 0. So the limit as theta approaches infinity is going to be 0, which says that this is going to at some point level out to 0, which it never will because it's going to keep on going up and down and up and down and up and down forever. So there's no limit as theta approaches. It just keeps going up and down. So D is not true either. So that's why C makes sense. Which of the following statements is false about the graph of the function f of x equals negative 4 cos x? Select all that applies. So, okay, so we could have several. So we're kind of playing 3 truths and a lie, or maybe 2 truths and 2 lies, or a bunch of lies, and it's all very anti-biblical if you ask me. I don't like it. But, oh my gosh, I'm leaving it. I'm leaving it in the video. Let's try to draw what negative 4 cos x looks like. First off, it's negative something cos x. Cos x usually starts up here, but now it's going to start down here. It's going to come back up, work its way up, come back down, repeat. Now, since it's negative 4 cosine x, it starts at negative 4 and peaks out at positive 4. All right. Nothing happens inside the parentheses, so the period is still 2 pi, which means it bottoms out at 2 pi, so it peaks out at regular pi. It crosses over at pi over 2 and crosses over at 3 pi over 2 like that. All right. So I have my graph. Let's find out what's true. The amplitude is 4. All right, so amplitude is half the distance from the very top to the very bottom. So to calculate amplitude, we would do 4 minus negative 4 over 2, which is 4 plus 4, 8 over 2. The amplitude is 4. Okay, oh, here, let's do this. Yeah, now no one will see that I almost circled it. That's true. We want the lie, so I don't want to circle you. The point 0, -4 is on the curve. Well, here's 0, -4, and yeah, it's on the curve. So since you're true, I don't want you. F of x is less than 0 on the interval 0 to pi. That means it's underneath the x-axis on 0 to, did I say 2 pi? Pi over 2 is what I meant to say. So here's 0, here's pi over 2, and it is under 0. It is under the x-axis, so this is also true in thick lettering. And last but not least, this has got to be a correct statement. F of x is concave up on pi over 2 to 3 pi over 2. So pi over 2 to 3 pi over 2 is actually concave down. So none of these, oh, it's false. I am failing at my own problems that I created. That's a lie, which means it's false, which means that's the one that I want. Whew. Make sure, make sure you like and subscribe and don't make fun of me in the comments. Or do make fun of me in the comments. Comments are good, so whatever you want to do. Which sinusoidal equation matches the graph below? All right, well, since I don't see anything being added or subtracted inside the x or whatever, this is going to take on a normal looking shape. It starts up here. And when it starts up there, that tells me that is a positive cosine x. Sine starts at 0, 0. Cosine starts above it. Now, not only does it start above it, it starts 3 units above it, which means as long as nothing shifts up or shifts left or right or shifts down, I have just a regular old 3 cosine x. I'm not worried about a change in a period. I'm not worried about any moving left or up or down or anything like that. I'm just worried about it starts up here. It goes up to 3, bottoms out at -3, repeats every 2 pi, like it does right there. Everything is good. Everything is kosher, fine and dandy like sour candy. The answer is B. Which sinusoidal equation matches the graph below? Here's my picture, and it looks like I'm not only dealing with amplitude stuff, but I'm dealing with periodic stuff, like I'm changing the number in here. So let's compare it to this function, y equals, and then I'll say a times whatever trig function is that we're dealing with, and then leave it at bx. Now, in later sections, you will have stuff going on inside and outside the parentheses. That has to do with a vertical or horizontal shift. We're not dealing with that here. We're only caring about 3 things. Thing number 1, what is the amplitude? Thing number 2, is it sine or cosine? And thing number 3, what is that b? Now, we find that b by doing 2 pi over whatever the period is. Okay, so that's how we're going to figure all 3 of these things out. Now, let's find out the amplitude first. The very tippy top is 3, the very bottom is -3, and the amplitude can be found by doing 3 minus -3 all over 2, which is 6 over 2, which is 3. The amplitude is half the distance from the top to the bottom. So the amplitude is going to be 3. Now, in this problem, since there's no shifting left or right, it starts right here at 0, 0, and then comes back up and down. It doesn't start up here. So this is going to be a sine function given the information that we have. And so I'm going to say this is sine. Now, last but not least is I need to find the period, so that I can plug it into that equation right there. If I do start at 0, go up, down, and repeat at pi, that means my period is pi. So what I'm going to do is I'm going to turn this into, let me get the regular marker, 2 pi over pi, which means that b is 2. So the equation that I can set up is y equals a, which is 3, sine, b, which is 2, x. And that matches up with B, baby. Which of the following statements is correct about the function g of theta equals 10 cosine theta over 2? I want to compare this to a cosine b theta. Okay, I'm not worried about shifting left, right, or up or down, so I'm not worried about adding or subtracting anything outside or inside. This is what I'm dealing with. I also want to rewrite this guy to kind of make it match up like that. So 10 cosine b, which is going to be 1/2 theta. Now it's asking me a couple questions, some of which is going to be amplitude, period, stuff like that. Let's find out everything we need to find out, okay? We'll find out what we need to find out. We'll graph it. We'll see what happens. We'll go from there. All right, so I'm building my graph. All right, there's my graph. My amplitude is 10. That 1/2 that lives in front of theta is going to be equal to 2 pi over whatever my period is. Okay, so if I kind of like look at this and cross multiply and say, all right, well, one period is going to equal 4 pi. So now I have enough information to say, all right, it's a regular cosine. I'm going to draw out a regular cosine. We're not moving left or right. So cosine starts up here, bottoms out down there, repeats up there. Okay. We know that since the amplitude is 10, we can say that you're 10. We can say that you're -10. Since it starts up here, it ends at 4 pi because that's my period, which means halfway through where it bottoms out is going to be 2 pi, where it crosses the x-axis is going to be regular pi, and where it crosses the axis again is going to be 3 pi. All right, it also is talking about midlines and stuff like that, and maximum values. Well, the maximum value is 10. The minimum value is -10, which makes the midline halfway in between those, which is y equals 0. So I have an amplitude of 10, a period of 4 pi, a maximum of 10, a midline of nothing, and a minimum of -10. Which of these is true? The amplitude is 5. Nope. The period is 2 pi. Nope. The maximum value is 10. Yup. The minimum value is -10. Yup. The midline is 10. Nope. The period is 2 pi. Nope. The amplitude is 20. Ooh, close, but nope. And the period is 4 pi. That's correct. And the whole thing ain't. So the answer is going to be B, baby. Which of the following is correct for the function f of x equals -2 cos pi x plus 4? I like to compare this guy to y equals a cosine times the quantity b times the quantity x minus c, close it, plus d. Now what this gives us is a gives us the amplitude. I used cosine, the same rules apply for sine, it's fine, but cosine, cosine. B is my frequency, in other words, 2 pi over my period. 2 is a horizontal translation, in other words, move left, move right. And D is a vertical translation, in other words, move up, move down. So let me rewrite this equation so everything lines up nicely. All right, f of x equals -2 cosine pi times x plus 4. Now what do we know? The amplitude lines up with -2. Now you can't have a negative amplitude, so you're just going to say that the amplitude is 2. Don't overthink it. Okay. Now in order for me to find the period, I match b up with pi. See, we're not adding or subtracting anything, so the number in front of x is still the number in front of x. So I'm going to say that 2 pi over my period is going to equal, we'll put pi over 1. That way we can do this by cross multiplying. So we could say that pi times the period is going to equal 1 times 2 pi, which is 2 pi. Divide both sides by pi. Lots of stuff cancels out. And you have a period of 2. Okay? We're not moving left or right at all. And then now we can also say that since this is plus 4, this is a vertical a vertical translation of 4. What this also means is if we move this up 4, that D is my midline. So my midline is going to be the equation y equals 4. So amplitude of 2, period of 2, midline of y equals 4, we are going to get B, baby. That's how you do it. A table gives ordered pairs for 7 points from a larger data set. The larger data set can be modeled by a sinusoidal function f with a period of 6. The minimum values of the data set occur at x values that are multiples of 6. So you are a minimum and you are a minimum. Ooh. What is the following, which one of the following best describes f of x for the larger data set? All right. So I'm going to compare this to the equation y equals a times whatever trig function it is that we care about. And it looks like in this case we care about cosine because those are my only options. B times x minus c, close it, plus d. Now, what does each letter mean? A stands for amplitude, amplitude. B is the frequency, which is 2 pi over the period. C is a horizontal translation, in other words, moving left or right. And D is a vertical translation, in other words, moving up or down, also known as my midline. Okay, so let's see if we can find stuff out. If I were to graph this out, okay, best as I can, and it's not going to be pretty, we have 0 at -4, and then 1 is -1, and then 2 is 3, and then 3 is 6, and then 4 is 3, and then 5 is -1, and then 6 is -4. Good job graphing by me. So it looks like we do have a cosine function that starts down here, bottoms out at -4, peaks out at +6. So we have to find our amplitude based off of this number and that number, which will also help us find our midline. So let's find our amplitude. Our amplitude is going to be the larger number minus the smaller number, divided all by 2. So 6 minus -4 is going to be +10. +10 over 2 is 5. Okay? That's my amplitude. My midline is very similar, but you add the numbers. 6 plus -4 all over 2, which is going to be y equals 2 over 2, which is 1. So the amplitude is 5, the midline is 1. Now, if I go up and then down, okay, this is my period right here. Okay, my period goes from 0 to 6. So in order to find B, B is going to be 2 pi over 6, which is pi over 3. I'm not moving left or right. So to build this equation, we have y equals the amplitude, which is 5, then cosine, by the way, I know that I'm not doing this completely correct. Give me a minute. Cosine of b, which is pi over 3, x minus 0, so just x, plus 1. Now here's the thing. If cosine starts here, and I'm not worried about shifting left or right, cosine's supposed to start up there. So we have to throw a negative in front of it. That's how I knew I wasn't right. So I have -5 cosine pi over 3x plus 1, which gives us a final answer of D. Given the function y equals -2 sine times parentheses 2x plus pi plus 1, which of the following correctly describes the horizontal and vertical translation? So I don't care about amplitude and stuff like that. I'm going to compare this to the equation y equals a times sine, b times the quantity x minus c, close it, plus d. What I care about here is the fact that you are going to be my horizontal translation. All right, so keeping in mind negatives make it look opposite, but this is where I care about my horizontal translation, so HT. This is going to be my vertical translation. Issue number 1, you don't look like you. You have parentheses inside the parentheses, you don't. So what I need to do is I need to make you look like 2 parentheses x something. So I have to take a 2 and rip a 2 from not only x but pi. So if I do that, when I factor out a 2, what I'm doing is dividing the 2 from both terms, which is why 2x divided by 2 leaves me with just x. Now what would happen if I were to rip away a 2 from pi? Well, you would get pi over 2 because you're dividing 2 from pi. So inside the parentheses, okay, so inside the parentheses I have -2 sine parentheses, parentheses. I now have 2x positive plus pi over 2. Now what that means is when it's positive inside the parentheses, you don't go right, you actually go left. So we're going to go left pi over 2. The easy part is the second part, and that's plus d, which is plus 1, which means we're just going to go up 1. Which I believe is going to be C. It is. Good job, everybody. You see what I did there? Which of the following sine functions matches the following attributes? The amplitude is 2, the period is pi over 3, the phase shift is left by pi over 6, the vertical shift is down 14. Well, we're dealing with the sine function, so I'm going to write out the standard definition of a sine function, sinusoidal function, whatever it's called. A sine parentheses b times x minus c, close it, plus d. Okay? A stands for amplitude, amplitude. B is my frequency, which is 2 pi over the period. C is going to be my phase shift. Okay, in other words, my horizontal translation. So this is the left or right part. And D is going to be the midline or the vertical translation, so up or down. Okay, so let's build this guy. Y equals amplitude of 2, A is 2. Sine is sine, close it. B is going to be, well, it gives me period, but I need to find 2 pi over period. So let's do a little bit of math. 2 pi over the period that we're given, which is pi over 3. Multiply the top and the bottom by 3 over pi because that's fractions. Pi's cancel out, and B is going to be 2. Parentheses. Why did I say 2? It should be 6. Ugh. 6, not 2. My gosh. So B is going to be 6. Now I have x minus a phase shift of left pi over 6, so negative pi over 6. So I'll deal with that double negative when I have to. Close it, plus negative 14, so minus 14. So cleaning this up, y equals 2 sine, parentheses, 6, parentheses, x plus pi over 6, close it, minus 14. And that, ladies and gentlemen, is going to give me A. I don't know why it took so long, but it did. I regret nothing. Thanks for watching. Free response question numero uno. This problem right here is very, very, very typical for a AP Precalculus practice exam. You see them a lot. So this is not something that I just pulled out of thin air. It's very typical for an AP Pre-Calc exam, or at least a practice test. So you might see one like it in May. You never know. The blades of this fan rotate in a counterclockwise direction and complete 20 rotations every second. Point P is at the tip of one of the fan blades and is located directly above the center of the fan at time t equals 0 seconds. So tip, top, don't stop, DJ, blow my speakers up. Kesha. Point P is 12 inches from the center of the fan. Okay. And the center of the fan is 30 inches above the floor. Okay. As the fan blades rotate at a constant speed, the distance between P and the floor periodically decrease and increase as seen right here. So right now, we're at the very beginning. It's at the top, then the middle, then the bottom, then the middle, then the top, and then middle, bottom, middle, top, blah, 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 blah. Spinning around, spinning around, spinning around. The sinusoidal function h models the distance between P and the floor in inches as a function of time t in seconds. The graph of h and its dashed midline for 2 full cycles are shown, as seen here. 5 points A through E are labeled on the graph. No scale is indicated and no axes are presented. So, problem A is to determine the possible coordinates t, h of t, so like x, y, for the 5 points A, B, C, D, and E. So here's what they look like. Now the nice thing about this problem is we know that P starts at the top, and so it gave us A to start at the top. So let's do this. Let's build our points knowing very well that the x value is t, which is time, and the y value is going to be the height at a given moment. Let's focus on time first, and we're going to build all of our points by focusing on the time, and then we'll worry about the height when we have to. Okay, not the most traditional way of doing it, but this is the way I want to do it. I'm starting at 0. Now, it rotates 20 times per second, which means it completes an entire cycle every 1/20th of a second, which means you're going to be 1/20th. Now, to find B, C, and D, you are comparing where B, C, and D are versus E. And then you're going to use a fraction to multiply it to 1/20th. So if I wanted to compare B to E, B is 1/4 of its way to E. So what we would say is B is going to be 1/4 of 1/20th of a second, which is 1/80th. So we will sneak a 1/80th right there. C is halfway in between. So C is 1/2 of 1/20th of a second, which is going to be 1/40th of a second. Last but not least, D is 3/4 of its way to E. So 3/4 of 1/20th of a second is going to be 3/80ths of a second. And I don't know why I put a 40 there. Silly me. Let's erase it. Got my mini eraser out, so let's see if I can do that without destroying too much. Hey! All right. So let me quick write that out, 3/80ths. So we have our t values. Now to finish these points out, these coordinates out, I need the height. What do I know? I know that the middle is 30 inches off the floor. I also know that the distance between the middle and that point is 12. So the very maximum is going to be 30 plus 12, which is 42. And the very minimum is going to be 30 minus 12, which is 18. So at the very tippy top, we're at 42. At the very middle, we're at 30. At the very bottom, we're at 18. At the very middle, we're at 30 again. And at the very tippy top, we're at 42 again. So determine the possible coordinates for A, B, C, D, and E. Well, A ended up being 0, 42. B ended up being 1/80th, 30. C ended up being 1/40th, 18. D ended up being 3/80ths, 30. And E ended up being 1/20th, 42. Now, again, these are all possible points. Technically, there's an infinite amount, but I think most people would rather start out with 0. I think that's the best way to go. So, problem A, donezo. Problem B, find the altitude of the data. This is much friendlier. The altitude is literally half the distance of the total height. And you calculate that by doing maximum minus the minimum, all divided by 2. So the maximum height was 42, minus the minimum height, which is 18, all divided by 2. 42 minus 18 is 24, and 24 over 2 is 12, which makes sense because we were told that the distance between the center and the tip of the blade is 12 inches. So it should make sense that halfway in between is 12 inches, which means halfway in between is 12 inches. So that's that. Last but not least, what cosine function fits the data? Now, I'm glad we are being asked the cosine because it starts out by looking like a cosine. So we don't have to worry about any horizontal translation or anything like that. No horizontal shift. We're not moving left or right. So the equation that I like to use is y equals cosine, or a cosine, parentheses b times x minus c, close it, plus d. A is for amplitude. B is going to be 2 pi over the period. C is a vertical translation, which I'm not going to worry about. And D is the midline. Now we know what the amplitude is. It's 12. So that's my amplitude. B is going to be the hard part. Now B, again, is 2 pi over the period. My period is how long it takes to complete a full cycle, which I wrote up here is 1/20th of a second. So this is going to be 2 pi over 1/20th. Now what I'm going to do is I'm going to multiply the top and the bottom by 20 and 20. That way that kills these guys out. And 2 pi times 20 is going to be 40 pi. So that's going to be my B. My midline is right there given to me. I mean, it even tells me that the dashed line is the midline. So my midline, D, is going to be 30. Since I'm not shifting left or right because this is a cosine, and cosine, a positive cosine starts at the very maximum, I'm in good shape. C is going to be 0. So let's put this together. Y equals A, which is 12, cosine, parentheses, B, which is 40 pi, parentheses, x minus 0, so I wasted a little bit of time there, plus 30. So to clean this up and finish this problem out, y equals 12 cosine 40 pi. X minus 0 is just x, so I'll just put x there, plus 30. So like I said, this is a very traditional AP Precalculus practice problem. Whether you see it in May, I don't know, but chances are you will see a problem like this at some point down the road, so I hope this helps. You are studying the motion of a simple harmonic oscillator that cycles every t equals 4 seconds. By the way, if you don't know what a harmonic oscillator is, just imagine a string, and on the bottom of the string there's like a weight or something like that, and it bounces up and down and up and down, so you can see that it's sinusoidal. Okay, you have collected a table of values representing the height h inches of the oscillator above a reference point. Write an equation in the form h of t equals a sine b times t plus c, all in parentheses, plus d. This is a calculator problem. So we're going to use sinusoidal regression in our calculator to help us figure this out. So let's go off to the side and see what happens when we do that. All right, time to get our sin reg on, which last time I checked, according to the Bible, we shouldn't sin ever. Hit stat, go to edit, and let's plug these points in. So while I plug these points in, now would be a very good time for you to run to the comments section and say, wow, that sin reg joke was absolutely hilarious. By the way, this is 11.7. If your eyes are bad, I apologize. And these are points, so 7.2. And by the way, you should be noticing that now these numbers are repeating, and that's because it's sinusoidal. It goes up and down and up and down and up and down. So make sure you don't make any typos, like I almost did just there. And keep working your way up and down until we get there. And then 11.7, and then 7.2. All right, so A is asking us to find the equation using sinusoidal regression, and then the other problems are going to ask us to use that equation to do something else. So I go to stat, I go to calc, and sin reg is somewhere down here, sin reg, there you is. And not only am I going to use this formula, but I'm going to store this regression equation so I can use it for later. All right, so let's go down to store. By the way, you never need any of this. I've never found a reason to use any of that, so I'm not sure what the point is. I'm not going to worry about it. Go down to store reg eq so we can save this into the y equals button. Hit vars, go to y vars, hit enter, and there it is. So when we hit calculate, yeah, it'll give us something, but now we can also use this for later. Okay, so we have 4.5, 1.571, 1.571, and 7.2. So let's go off to the side and write that out. All right, so we ended up with h of t equals 4.5 sine parentheses, 1.571 t plus 1.571, close the parentheses, and then plus 7.2. Predict the height at time t equals 17.5 seconds. So that's just a simple matter of us using the equation that we stored in the calculator and finding out what happens when we plug in 17.5. Let's see what happens. All right, so B is asking us to predict the height at time t equals 17.5 seconds. So if I were to go to my graph, I'm not going to get 17.5. My bad. If I were to go to my graph or my table, I'm not going to get 17.5. Also, if I were to hit graph, I still won't see 17.5. So if I try to do the whole value thing, it won't let me because 17.5 is not on the screen. Watch it yell at me. So what I need to do is I need to extend my graph so that I can find the value at 17.5. Now looking at C, we're going to need also to use the point 22.2. So I'm going to go to my window. I guess I have to quit this first. I'm going to go to my window, and I'm going to keep everything the way it is, but I'm going to change my X max to 30. Okay? X max is now going to be changed to 30. So when I go to my graph, or I'll hit graph first, there it is. Now when I go to calc and do value, I will be able to type in 17.5. So it's just one of the flaws that the TI-84 Plus calculators have. But by doing this, we get 4.018. So let's go off and write that out. We ended up with 4.018 inches. All right. Find the average rate of change for the first 22.2 seconds. So the average rate of change formula is going to look like this. So what I need to do is I need to run to my calculator, find out what happens at 22.2, then minus, I already know what happens at 0. It's the first 22.2 seconds, so that's going to be 0. So I'm going to take whatever that number is, minus 11.7 over 22.2 minus 0. So let's see what happens when we do all of that. All right, so let's use that formula. We have the average rate of change. Now, we don't know what the average rate of change is yet until we find out what happens at 22.2 seconds. We do know we're going from 0 to 22.2. So the nice thing about this is since we have 0 there, all I have to do is look at my table to find out what happens at 0, and that's 11.7. Okay? Now, at 22.2, we can do the same thing we did for part B and type out value and do 22.2. And that's going to get us 2.92. 2.920, but we're going to stop at 2.92. So to set this up, all right, we're using the formula f of b minus f of a over b minus a. So this is going to be f of b. 2.92. So let's quit out of this and do 2.92. Now, if you remember, the table started you out at 0 with 11.7. So we're going to do 11.7 as our f of 0. Now we divide that by 22.2 and then waste our time a little bit and say minus 0. This is all we need. This is the average rate of change formula. Hit enter, and you get negative 0.395. Okay, so let's go back and write that out. All right, so what we did is we did 2.92 minus 11.7 all over 22.2 minus 0, which ended up being negative 0.395 inches per second. Okay? So that's free response question numero dos, baby.